Good afternoon, everyone. Once again, welcome back to Shanavaseshwar College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer Jagadish. Okay, your BSc 5.2 Laplace transformation classes are going, and in last class we discussed about your property number 7. It is periodic function of a Laplace transformation with period t. Okay, and also we solved some examples related to that periodic function property, and today I'm going to take your next property, that is unit step function. Unit step function. Uh, in last class, I only explained the definition of that unit step function property. So today there is a one theorem on that property. Okay. Okay, guys. In last class, we see the definition of unit step function. So today also I'm going to take one more repeat. It is definition of unit step function. The unit step function is denoted by u of t minus a. It is u of t minus a, and it is defined by u of t minus a is equals to 0 and 1. Okay, you guys already know that is a periodic function. Okay, periodic function with period t. On that we see f of t plus t. Okay, like this type only we have negative term, and that negative term we call unit step function. Okay, so in negative term, in u of t minus a, in negative term we will get two values. Okay, we will get two values. First one is 0 and second one is 1. Okay, 0 for when t is less than or equal to a, and 1 for when t is greater than or equal to a. Okay, so same here, f of t plus t have, that is f of t only, and here we have u of t minus a is equals to two values 0 1. T when 0 when t is less than a, 1 when t is less than or equal to a. Okay, and we have one more theorem related to this property only, that is unit step function property. We will see that one first. Okay, see here your next property, that is unit step function. One theorem is there. It is Laplace transform of unit step function. Okay, Laplace transformation of a unit step function, and the statement is Laplace transformation of u of t minus a is equals to e to the power minus as divided by s. Okay, this is the statement. We have to prove this one. Laplace transformation of u of t minus a is equals to e to the power minus as by s. Okay, let me prove this one. Proof. And we have, by the definition of our Laplace transformation, we take Laplace transformation of u of t minus a. Okay, this is called f of t, and we have our definition, that is integration over 0 to infinity e to the power minus st f of t dt. Okay, this is our definition, and this whole term we will take f of t, and we write here it is integration over 0 to infinity e to the power minus st u of t minus a. Okay, this is function, and with respect to dt. Okay, and here we have wait. Okay, and here we have two limits. It is 0 to a to infinity. Okay, so that's why we'll separate it one. That is first function, integration over 0 to a. Integration over 0 to a, and first function, that is as it is e to the power minus st u of t minus a dt as it is, plus the second term means integration over limit a to infinity. Okay, a to infinity, and remaining e to the power minus st u of t minus a dt as it is. Okay, okay, now and we have, according to our unit step function formula, unit step function formula, when t is less than a and when t is greater than or equal to a, we have two values here. It is t is less than or equal to a, on that time we will take 0, and when t is greater than or equal to a, on that time we will take 1. And in this term we will take 0 to a limit is there, okay, and 0 to a limit is there. It means t is less than or equal to a. In that term we will take f of t, this u of t minus a function as 0, and second function integration over a to infinity, okay, a to infinity, and this time we will take the value of u of t minus a is equals to 1. Okay, this is by your unit step formula, that is unit step function definition, and this whole term will become 0, and this term, when we integrate this term with respect to dt, one is negligible value, and integration over 0 to infinity e to the power minus st dt we have only, and when we integrate this function with respect to 0 to infinity limits, on that time we will get e to the power minus st by minus s, and limits are 0 to infinity. Okay, so here this function only, it is integration, e to the power minus st divided by minus s, and limits are a to infinity. Okay, when we apply the limits here, upper limit minus lower limit, it means e to the power minus s into, means e to the power minus infinity divided by s minus e to the power minus s into a. Okay, minus s into a, this is your lower limit, divided by minus s as it is. Okay, minus s as it is, and this whole term becomes 0, and minus into minus we will get plus function e to the power minus s a divided by s. Okay, so this is our RHS side, and final resultant answer is, it is Laplace transformation of u of t minus a is equals to e to the power minus s a by s. Okay, so this is your one small theorem related to that your unit step function property. Here we have, it is Laplace transformation of unit step function for theorem is there, and we will go for next property, that is important property, second shifting property. Okay, this one is important property. So using that unit step function only, we can easily solve this property. It is second shifting property. Okay, in previous we studied first shifting property, and this one is second shifting property. Okay, so this statement is the second shifting property, property number 8, and this statement is, if Laplace transformation of f of t is equals to f of s, then Laplace transformation of f of t minus a into u of t minus a. Okay, here we will get two terms, is equals to e to the power minus as into your remaining f of s. That means when we will get this type of problem, that means this type of equation, in that time we will write only e to the power minus s a into Laplace transformation of one given equation. Okay, and the proof is, first we will write our given equation, that is Laplace transformation of f of t minus a into u of t minus a as it is, and according to our definition, Laplace transformation definition, we will write this function as integration over 0 to infinity e to the power minus st. This whole term we will write it as f of t, that is f of t minus a into u of t minus a with respect to dt as it is. Okay, and here also we have two limits according to our unit step function formula. Here when we separate this function, that is integration over 0 to a limit first limit, and integration over a to infinity or second limit. Okay, separate this function, first function, that is integration over 0 to a e to the power minus st f of t minus a into u of t minus a dt plus your second function integration over 0 to integration over a to infinity e to the power minus st f of t minus a into u of t minus a dt. Okay. So again we will take the values of f of u of t minus a value. Here we get 0 and 1 when 0 a is less than a, and when 1 on that time we have t value is greater than a. Okay. So here we have 0 to a is limit. That means our the given function u of t minus a value is 0, and here a to infinity is there. It is u of t minus a value is 1. Okay. So we'll take this function only. It is integration over 0 to a e to the power minus st f of t as it is, f of t minus a as it is, and this whole term becomes 0 according to your unit step function formula. And here second term, it is integration over a to infinity e to the power minus st f of t minus a into this whole term will take 1 into dt with respect to as it is. Okay. So here we have 0 term. That means in this whole term will become 0 plus integration over a to infinity e to the power minus st f of t minus a into dt. Okay. Into 1 is there, so we will neglect that one. It is integration over a to infinity e to the power minus st f of t minus a into dt. Okay. And we'll get here we will get and call this as equation number 1. It is integration over 0 to infinity e to the power minus st f of t minus a into dt. Call this as equation number 1 and put some values, means some changes here. That is t minus a is equals to v. Okay. T minus a is equals to v, and with respect to differentiate dt we'll get dv, and limits are t tends to a, that means v tends to 0, and t tends to infinity, v tends to infinity. Okay. These values substitute in equation number 1. Okay. Now Laplace transformation of your LHS side, that is Laplace transformation of f of t minus a into u of t minus a is equals to here integration over v. Okay. V 0 to infinity e to the power minus s into t value is here means t minus a is equal to v. So only t value is v plus a. It is v plus a into f of t minus a is v, and dt with respect to is dv. Okay. So this function only we will write here as integration over v is equals to 0 to infinity, and here e to the power minus s into v plus a is there, and when we separated this function we will get e to the power minus s into v and e to the power minus s into a. Okay. And this term as it is, that is f of v into dv. Okay. Now here we have e to the power minus a as function. This function is becomes constant, so that's why we take as outside, and remaining integration over v is equals to 0 to infinity. Okay. Or 0 to infinity e to the power minus sv f of v dv. Okay. So see here carefully. So this whole term we will take it as f of or f of t. It is our Laplace transformation of this function. Okay. So e to the power minus as it is, and this whole term we will take it as Laplace transformation of f of t. Okay. Or we can write it as Laplace transformation of or capital F of s. Okay. And our final resultant answer is Laplace transformation of f of t minus a into u of t minus a is equals to e to the power minus as into Laplace transformation of f of t. Okay, means e to the power minus as into Laplace transformation of f of t. Okay, I hope you guys understand this function in this property. Okay. So today's class we solved first theorem, that is theorem of unit step function theorem, and this segment is Laplace transformation of u of t minus a is equals to e to the power minus as by s, and your important property is second shifting property. Okay, this is second shifting property, and the segment is Laplace transformation of two functions is f of t minus a, u of t minus a is equals to e to the power minus as into your remaining Laplace transformation of f of t.